everyone. My name is Yogesh. So I will be presenting you how the query optimization. So this whole performance optimization is divided into, you can say, two different parts. One part will be like query optimization, how you optimize the query, and the second thing is when the production server has issues or when it is not even having the issues, then what you check on the production to see what you have to do to ensure the performance of that particular production server. So give an example. So when I say like a query is running bad, so generally what is the parameter when you say like, okay, this query seems very bad? Is it the time it takes to complete the query, or what other parameter do you check whether the query is heavy or not? Can anyone give an answer to it, please? Fred?
Yes, I think Ayub can answer. Ayub.
Uh, okay. Time is important, of course. When we say query is running slow, we have to also see like the physical reads that the query does, the logical reads. If it is reading more than it is supposed to, or if the query is not narrowed down to search few records, we can also say a query is going to run slow.
Correct. Your answer is absolutely correct. So generally, most of the time, what we generally do is we take only the time as a parameter. But when he says like physical read and logical reads, so that is the main key to it. So more the logical read is, your query will, you can say, run slow. Now the thing is, when we have a query where it is taking a lot of reads and it is taking a lot of time, so time is always, you can say, very much like related to the number of reads you are doing. Let's say you are reading 1 GB of data, it will be a little bit slow. And then when you're reading just 1 MB of data, it is kind of fast. So the whole concept is the read define how much time your query will take. There are two parts of the, you can say, a query. One is like, you can say, physical read, logical read, and then it comes to time. Now time is also divided into two. One is CPU time and one is, you can say, actual time. So I will demonstrate you a very good example. So you can see this is my machine. It's an 8-core machine. So it's a good machine with 2.31 GHz with 16 GB of RAM. So it's kind of a good machine to run any one query. And I will demonstrate you one simple query which will cause trouble to this complete system. Okay. So if I just run this query right now, if you see my SQL Server usage, let's come to it. So my CPU usage is like less than 20-30%. Now, if I just run this query, what happens is my CPU usage jumps to 100%. And it's just one query, not a regular, like you can say, not more than one query. Just one query can make your CPU usage to go 100 times. You can say 100%. Now, think about if someone triggered this query 100 times in a minute. You can say once every second it runs. So, and now if you see the query has completed in 14 seconds and CPU has relatively came down. If I run it again, and you will see it goes haywire. Again, it went to 100%. So it's just one single query. So there might be other queries, like when you are talking about a production server, there might be other queries as well, which is doing the same thing. So as a DBA, our job is not just to identify the queries and tell people, okay, optimize your query. No, we have to give them the suggestions saying, if you change the query in this manner, it will be better. Now, to do that, we need to know how an execution plan works. Okay. So now, as it was been said, like we use logical reads. You can say whatever the input output happens and the time corresponding. So what I will do is I will just, is there any question? Sorry.
No,
Okay,
actually,
interrupt me.
there's no question. People are just joining.
Okay, no problem. So now when you analyze a query, now what you have to do is you have to use this set statistics time and IO on. This is a session level, means if you are running on this particular window, only in this window, this statistics and IO time will come. Okay. Now, if I just do it, then I will be able to actually get what is happening into this, you can say, query. I will enable the execution plan. It will take some, you can say, 20-30 seconds. In the meantime, I will explain you. So when we see an execution plan now, so first thing is as a DBA, first you identified the number of, you can say, which are bad queries. And anyhow, in the next upcoming session, I will show you how you figure it out which queries are bad for your server. I am very, you can say, raw DBA, so I don't go for the tools to verify which query is running bad. I run queries and get the stats and work out on those particular things. So I will share you those queries as well, how you can download the stats, how you can play around with the stats and other things. So when we see an execution plan, now we have to look into the operator precedence. Whenever you see certain thing in, you can say, execution plan, now, and those things are always a red flag. So they have a precedence. Let's say if there is an operator A, then you have to fix the operator A first, and it will have, you can say, 100% different impact on the query. Okay.
Ganesh, I think there is a question. Uh, I think there are some folks here who doesn't know what the execution plan is. If you can talk about execution plan a little bit, what
Okay.
estimated execution plan and actual execution plan is, and then how they can uh,
Yeah.
get execution plan, it would be nice, because we have some folks who are completely 100 level, and then we have like 300 level. So it would be nice if we take those
Sure.
into consideration.
That's a good feedback. Thank you. I will take it from there. So here you see on your SSMS. So first of all, a lot of time I've seen like the people who are working as a DBA, they doesn't understand the SSMS itself. That is one of the key thing. SSMS is your friend. You need to know each and every option here. Okay. So right now, as Fred has pointed out, there are two things. One is actual execution plan. There are actually three: actual execution plan, live execution plan, and then we have estimated execution plan. Now, what is an execution plan? When I wrote a query, I said, okay, send me the students where their date of birth is the most, you can say, the most biggest date of birth in the student table. Now, what happens is I'm trying to find out the most youngest person in each, you can say, year. So every year, like let's say 2012 session and 2014 session, I want to find the youngest student from that particular session. Now, when I define a query, SQL Server doesn't start executing the query the moment it comes. First, it prepares an execution plan. Okay. Now, what is execution plan? Let me just show you an example. So this is an estimated execution plan. Estimated execution plan means it is not running the query. It is telling you intent of SQL Server. This is how a query will run. Okay. Now, when so the option I clicked is this particular one. Here you see display executed estimated execution plan. If you want to get an actual one or live one, you have to click on these two. Now, what is the difference between actual and estimated is estimated execution plan is always based on either the query is new and SQL Server is creating a plan for it, or from its past execution, this was the plan. So estimated execution plan is not an actual one, but most of the cases you will find they both are equal. Okay. Now, when you see an execution plan, let me zoom in into this execution plan so that you will get an idea. I think I cannot zoom in. Oh, that's bad. Oh, I can. Yeah. So this is execution plan. Now, in execution plan, data always flow from right to left. So means if you see now, when I said student table, so you will see at the end there it's using student table. So what it is doing is whenever you put in where condition, okay, I have a question. A join execute first or a where condition? Can anyone address it? Fred, would you like to give an answer to it? And please don't hesitate. Answer can be wrong. We are here for learning, so it's not about any test you are giving. So okay, let me just give you an we can say clarify. Whenever you run a query, first thing works if your where condition doesn't have any expression and other thing, your where condition will run first, because when it selects the table itself, it will start, you can say, filtering out the table itself. But the moment your query becomes a correlated subquery or an expression in a where condition, it cannot run, you can say, in the first. So what it has to do is it has to compute and then it has to join and give the output out. Okay. So this execution plan shows you how SQL Server will flow. So when you say, okay, so we know, okay, there are 3, 4 types of join, like inner join, outer join, and then cross join. But if you see now here, it says nested loops. There is nothing like nested loop in my query. But this is a language what SQL Server understand. So when you give an query to a SQL Server, it creates the execution plan, and the your join translate into different operators. So these are called different operators. So this nested loop is one type of join. There is merge, join, and when the table are big and all, that we will cover sooner or later. So that should not be an issue. But execution plan tells how the SQL Server works. Now, when I'm optimizing a query, I have to see what execution plan it is making. If the query takes, let's say, 1 hour to run, so definitely you won't be running the query. Then it's better to go for estimated execution plan. But if it queries, let's say, take 20-30 seconds, then it's always good to go with the actual execution plan, because sometimes plan might change when query goes for execution. Okay. Now, in this particular, you can say execution plan, what do you think? What is the most problematic one? This query was making my SQL Server go 100%, am I right? And it took 16 seconds to give 384 records. And just to give an idea, so student table is not a very big table. It's less than a 5 MB of size. Let me just show you. So if I go for the student table, so let's go for storage. It's less than 6 MB. So it's a small table. And for a machine with 16 GB of RAM, it's a relatively small thing to, you can say, work around. Then what you see in this execution plan, if you haven't worked on execution plan, just ignore it. But for the people who has already worked on execution plan, what do you see wrong in this execution plan?
The table scan,
Table scan, okay.
the 100% goes out.
So this table scan says 56%, and then there's an aggregate 42%. But what
On the
if I say
table.
like this? Sorry,
We have a couple of table scans.
couple of table scans. So table scan is a problem. So okay, now let me give you one more thing. We have something called as index seek, index scan, and table scan. So now when we see the seek is the one of the best thing if your execution plan is doing it. But let's come to scan. Does anyone know what is difference between table scan and index scan? Okay, let me answer that question. So table scan, whenever you see the table scan, that tells there is no cluster index on the table. That means there is no primary key. Generally, when the primary key is the mostly the cluster index. So the moment you see the table scan, that means the table is lacking a primary key. Okay. And when you see index scan, so when the table has a primary key, by default, it will go for either cluster index or non-cluster index scan. Okay, everyone that at least everyone knows, like, we can have only one cluster index in a table. Am I right?
Yep.
And more. So what is the difference between cluster index and non-cluster index other than this?
Again, Yogesh, I'm sorry to interrupt. I think there are some folks who doesn't know what clustered and non-clustered index are. They're pinging me. If we can
Okay.
talk a little bit about index, it would be nice. I'm not trying to interrupt, but it would be nice to do that. Thank
Yeah,
you.
that's it. No, you're doing the right job, man.
Mhm.
So you are setting right pace. Okay, so what is cluster index? Okay, let me give an example. So there is a this is generally a most common interview question. What is the difference between cluster index and non-cluster index? Now, what is let me explain. When you create a table has columns into it, am I right? Now, when we have columns and then we have rows. Now, the main difference in cluster and non-cluster index is, like, we can have only one cluster index in our table and not more than, and we can have more than one non-cluster index. Now, why only cluster index has to be only one? Because actually the table itself is a cluster index. All data sits on a cluster index. That's why it is only always one cluster index. You cannot have two copies of cluster index. That means you have copy of table. So by default, when you create a primary key in our SQL Server, so let's say this customer table. So if I go with the key, I can see a primary key is the, you can say, when I created this table, so the primary key is the, you can say, customer ID. So this is a primary key. The moment you create, what it does, it creates the cluster index. Here you see it shows you clustered. So by default in SQL Server, primary key becomes the cluster index, but it's not mandatory. If you don't want primary key to be cluster index, then you have to create a unique key, and on top of it you can create a cluster index. Now cluster index, now when it comes to index, so index is nothing but like a book index. So when you say, okay, find me the person who has ID, let's say this is my records. So this is ID 1 2 3 4 5 6. Let's say if I ask Fred to query where the where the ID is 3. So how it will go is, one way is like he will check, okay, what is the ID here? Is it 3? No, it's, is it 3? Is this 3? Is it 3? Is it 3? Is it 3? And it says, okay, this is the only one 3. Okay, let me return this data. So this is traversing. This is called a scan, where you have to scan each and every value. Now, what generally in when the your, you can say, index is properly created, and you say find me 3, what SQL Server will do is, as index is in either an ascending order or descending order. So index, so in a book, when you open your book, and let's take an example of any book. Let's take an example of archive org. You will get an idea. Let's go for any book and open, let's say, this particular book. Oh my god, this is different language, sorry. So let's go for comic books. Okay, let's take this particular one. So it says like this information is on, let's say, page number 5, and this information is page number, let's say, 10 or 6. Now this is nothing but an index where the topics are arranged based on their phone number, you can say page numbers. You will never have a page number. You can say, okay, this topic is on 100, let's say this topic is on the 100 page number, and then it says this topic is on 1. Index is always arranged in an either ascending or descending order. That can be page number, or that can be topic names. Similar way in SQL Server, when we create an index, by default, as I told you, when you create the primary key, it becomes cluster index by default. And when you create an index, what it do is it ensures the data is sorted as per that ID or that particular column. That means it's always in ascending order. So when I'm looking data which is already in an order, for me finding 3 is not a big task. Give an example. Let's say I increase this list to, let's say, 7, 8, 9, 10. Now I have to get 3. So first, what SQL Server will, it will find out the middle point. So 5 is the middle point. Then it will say, is this a 3? No, it's a 5. Is 5 greater than 3? Yes, it's greater than 3. The moment it knows it's greater than 3, it has to only search into the remaining, you can say, initial part of the index, because it knows if 5 is greater than 3, then everyone else after 5 is also greater than 3. Now what it will do is, again, it will take this subset, find the middle point. Middle point is 3. Is 3 equal to 3? Yes, it's 3, and it will return you the 3. So the index is, when we say cluster non-cluster index, that means it is keeping a data copy which is either ascendingly arranged or descendingly arranged. Okay. Now when we say scan operator means, let's say I have an ID column, and then I have, let's say, ID, name, and date of birth. Okay. Now I have primary key on my ID, which is like 1 2 3 4 from there to 10 and further on. And then we have date of birth. I say, like, find me all the people who was born in 1991. But this date of birth doesn't have any index. So what it will go is, it will go for clustered index scan. Index scan. Because only ID is the only one which is in ascending order. So what it will do is, it will go for, okay, it will take first record and say whether the date of birth is 1991. No. Then this record is date of 1991. Yes, return this record. Is this having, this record has 1991? No. So it has to go from first record to last record to give you the output, because it's a scan operation, because date of birth is not having any index on top of it. Now, definitely scanning each and every value doesn't sound performance wise good. So generally what our job is to do is, like, we need to find out whether that query is a frequent running query, or it's a long running query, or it's occasional query. So let's say there is a query which runs in 2 hours, but you run once in a year. It doesn't matter. Yeah, I don't have to optimize that query much. But if a query which runs 1 minute every day and 1,000 times in a day, I need to optimize that query, even if it takes 1 minute, because I want that 1 minute query to be super fast. How I do it, I will ensure there is no scan happening into the table. If scan is happening, the table size should be very small. Generally, if your table has like say 10 records, SQL Server will never go for seek. It will just scan through all each and every records. But if your table has a million row, then SQL Server will go, okay, if the column you are querying on is having, you can say 1 2 3, like in an ascending order, it will use this ascending order and translate to find the midpoint, and then again midpoint till the time you find out the value. And this operation is called a seek. But if it has to traverse from first row to last row, then it means it's a scan. Does that make clear, or anyone has question on it? Kindly feel free, please, you can ask any question.
I think it's good, but for some folks who doesn't know what index is, it's a database object that SQL Server uses, to get to the data faster. So basically, like Yogesh said, you have a clustered index and a non-clustered index, where cluster index is the table itself, sorted according to that cluster index key. On the other hand, the non-clustered index is basically a skinny page that SQL Server takes a column that you find a non-clustered index on, and it will create a skinny page. So it's a separate structure, whereas clustered index is, the table itself sorted according to the clustered index key value.
Yeah, just to add on top of it, as he said, like it is help us to improve the performance and speed, but we cannot create infinite number of index. It's not about like SQL Server doesn't support it, supports. The problem is index is nothing but copy of data. Means when you create an index on date of birth, it will create a separate copy of data where date of birth is been sorted in an either ascending or descending order. So when we create index, we always has to keep in mind whether the table. So generally, I divide table into three categories. One is master tables, which generally don't get updated every day. Then it's like semi-transactional, and then I say super transactional table. So if the table is master table, you can create infinite number of index. Let's say it has 10 columns, you can have index on 10 columns. Should not be an issue because it doesn't get updated. Let's say there is a table which is semi-transaction. Semi-transaction, let's say in a day you have 10 or 20,000 records coming up. That's a semi-transactional table. And then the super transactional table come where every second update, delete, inserts are happening. If it is just an incremental table where only inserts happen, you can create the index. It should not be an issue. But the moment you have update and deletes, you have to be very sure whether that table, that index is required or not. So let's say the query takes 10 minutes to run, and person says it takes time. Can I optimize it? And you figure it out. Okay, if I add more index, it will cause trouble to my table. So I will say, okay, wait for 10 minutes and pull the data in 10 minutes. Unless I have to give him some other alternative where we can pre-prepare the data and all. Because we have to be very sensitive when it comes to super transactional table. And as a DBA, you might be working on multiple databases which you have never worked before. So you always have to take help of developer knowing what category of the table is. It's a super transactional. He will say like everything happens. Like give an example. If it's a banking system, accounts will be kind of a super transactional table. Audit logs will be super transactional table. When it comes to your profile information, it's a semi-transactional. So you can have indexes. But again, index is nothing but copy of data. More index you create, more DBA maintenance time increases for you. And you have to ensure everything is up to date and so on. Okay. Anyone has any question here?
If you can talk about the disadvantage of indexes, I think that is also one of commonly asked, interview question.
Yeah,
I will show. It helps. Go ahead.
Yeah, I will demonstrate that with an example. Okay. So now, Fred, you said like we have index scan here, am I right? Table scan. Let's get rid of that particular thing. What I will do is I will go into the table. I will create a primary key and save it. Okay. So now my table, if I run the same query again, you can say try to get the execution plan. Let me just get it here. So if I try to get the execution plan, now here you will say, see, table scan has changed to cluster index scan. As I told you, cluster index is nothing but the table itself. That's why you can have only one cluster index. This is one question where mostly people fail in the interview when they don't know about the cluster index. What is the difference between table and the cluster index and non-cluster index? By just saying it, you can have only one, that doesn't justify it. Why only one? Because that is the actual table. So that means data is sorted in that particular order. So now, Fred, I have added that in, you can say primary key. Query is still making my CPU crazy. It doesn't help because it has converted into table scan, the index scan. Now, one more thing. Let's say you have a table scan and index scan, and especially the cluster index scan, they are equally awful. None of them is better than the other one. But the thing is, tables scan means the table doesn't have primary key, and it's a bit concern. So most of the time when I go review the people system and say, and they show me their production system and they say what is wrong with our system, first thing I check is how many tables are without the primary key. If I found, let's say, 100 of the tables and I asked them like how frequently you query, he said like, okay, every minute I query this table, then it's a red flag. Every table should have a cluster index or a primary key, else your data will never be in an order. And that not in an order means fragmentation increase. Now let me, as I told you the term fragmentation, let me explain you what is fragmentation. Okay, so we have this record from 1 to 10. Okay, now index knows it's an ascending or descending order. Let's say if someone says, okay, delete id 6, and then someone says delete id 2, and then someone says delete id 9. Now this is nothing but empty fragments. Now SQL Server has to figure it out. Okay, next ID to 1 is not 2, it's 3. Next ID to 5 is not 6, but 7. Next ID to 8 is 10, not 9. So to remember that, what happens is SQL Server has to do a lot of operation just to maintain that particular thing. So whenever there is you can say a table which is having a lot of updates and deletes, we generally, you can say, reorganize or rebuild the indexes. What rebuild will do is it will remove the data, you can say empty spaces in between. When I say fragmentation, that is the second check I do, and we will go through the query how I do that and all. But let's come back to the query. Now here my table scan has converted to index scan. It has saved me 3 seconds from 16 to 13, but it's still a bad query because it makes my CPU go 100%. See, again, my CPU is normal. Again, I run the query, it goes 100%. Just one single query. You can think of an impact. Like if one single query can make a CPU with 3.1 GSZ to go 100%, that means if this kind of query, 100 queries are running on the server, they will make the server crazy. So now coming back to the execution plan. Now, Fred, or anyone who want to reply. Now, what you see, what is the problem with this particular execution plan? And don't get into the SQL query definition. I made that query bad just to demonstrate you this. Okay, so what you think? What is the problematic area? Anyone would like to make a guess? In execution plan, you see the cost 0%, 0%, and then you see 56%, and then you see 42%. That means how much time your CPU, you can say your SQL Server has to spend on this particular operation. So the most heaviest one, the 56. Is that right?
Yeah.
But now here the craziest part. In this whole execution plan, this is the problem, lazy spool, which it shows cost 1%. Because in SQL Server, you need to remember data flow from right to left, and logic flows from left to right. Means the logic to get the data is coming from left to right. Okay, that means this is what which is telling what to do, and in this part of the query. So now it says 1%, but it's not actually the 1%. It's 1 plus 42 plus 56, which makes 99%. So 99% of your CPU cost is going bad is because of this. Now, this is one of the most expensive operator in SQL Server. The moment you see lazy spool in execution plan, it will be a problem. So this is so I am trying. I what I will do is I will show you, like, you can say line by line, what to look. So first, whenever you see a query, see if there is a spooling, especially the lazy spool. The moment the spooling happens, it will make your SQL Server crazy. Now, what is the reason for lazy spool? Okay, lazy spool can happen because of multiple reasons. One, it can be, you can say, recursive CT, or duplicate aggregation. Okay? Now, let me explain you this with a practical example. Now, if I ask Fred how many people came, he will say 62 people came. Am I right? Because the count shows there are 62 people into the meeting. But if I ask Fred to give me each and every person information, but with every record, tell me how many students came, answer doesn't change. When Fred is giving me Antish K information, or Ashu A information, again, it's an individual record, but the count for all the people is always 62. So if I ask him to do one thing, I say, get me all the people information, and every record, count how many people into the class came. Then doesn't matter how many records came. The answer to number of people will be always 62. But to do that, SQL Server has to recompute every time. It has to duplicate. It has to perform duplicate aggregation. Means every time it is counting how many people came into the class, even though answer is always the same. So whenever there is a select statement, and when there is no recursive CTE, recursive CTE, I know, like, you might not be, not all people will be familiar. I will. There is a SQL developer lesson. If we require, I can do it at the end. So in end of the sessions, in that I will show you how to write recursive CTE and all. It comes very handy when it comes to, you can say, rewriting query and all. But recursive CTE is not a bad thing, because we cannot ignore that. Whenever it is required, it's required. But duplicate aggregation we can fix. Am I right? I am asking it to. So let me explain you this query now. I said, find me the youngest person in every year. So to do that, I said, okay, get me the student, join with the student year, and find me the maximum date of birth. Maximum date of birth means the person who is born on 31st of December is always younger than the person who has born on 30th of December. He is younger than by 1 day to the person. So now this is what I'm trying to do. But what is happening is, as it's a correlated subquery, what is happening is every time it is making a join and then recomputing what is the maximum DOB in that particular year. Now that means if in 1991 the maximum DOB is 31st of December, doesn't matter how many times I compute, it will always remain 31st of December. So the answer to youngest person in 1991 doesn't change. But as I have made it correlated subquery, it will fetch all the record for student, and for every student it will go and say year of that student is 99, let's say 2000. In 2000, how many, what is the maximum DOB from all the students? So this is not changing. So this is nothing but duplicate aggregation. So the moment you see, you can say, a lazy spool in the execution plan, and you see a group by or something in, you can say, in the query, that means it's doing duplicate aggregation, and there are plenty different ways to fix it. Is everyone on board till now? Any question?
Guys, feel free to ask question. This is supposed to be an interactive session. I think Asfo is raising his hand. Go ahead, Asfo.
Thank you. I have two questions. One is on the execution plan. You said we have about three execution plans, live and
Estimated
so my question is on, you said live. Do we have a separate, or there's something that we do, like kind of scheduling, that we can see plans as it is going on, or what does that mean?
Yeah, you can see the data flow going on. Let me show you live execution plan. So if I run it now, you will see it will show you the data flowing up. Like right now it's 0% and all now. So till the time it is computing, now here you will see the numbers going on. Right now it is keep on executing. Here you see numbers are changing.
Right.
Right? So this is nothing but telling you how at this particular time what SQL Server is doing at what particular you can say on operator. But frankly speaking, as a like my experience, I never used live execution plan. Most of the time I use estimated or actual. When the query is short, less than let's say 30-40 seconds, I go for always actual execution plan, because sometimes you see an execution plan, it might not show you the lazy spool because it's a cached execution plan. But when you run an actual one query actually, then the actual the plan will show the lazy spool. So most of the time I go for either actual or this one. Live execution plan, I am always confused, like why SQL Server even want to show us. Like I don't want to see how the data movement is going on each and every operator. I just know this is a bad one. So it totally depends upon you what you want to see. But live execution plan is nothing but it tells you how the data is or which operator is parallelly performing at what time. Does that answer
Okay.
your question?
Yes, it does. Thank you. My other question is related to index. So you said when we are creating an index, it is like a clustered index. It is like keeping a copy of the data. So my understanding so far was like when we are creating an index on a table, it's like physically rearranging the data in the table. So
No. It don't do. So I will give you an example of it. Okay. Actually, I haven't prepared those DMV queries. I can show you later on, but I will give you a simple example. The moment you say, I want to create an index on this particular table, let's say I want to create an index, let's say non-cluster index, because by default, primary key is the clustered, so it won't allow me to create another one. And I say add. So when I say add the thing, and I say first name and last name, and press OK, and just create this index. Now, a lot of time, what people do is they will add primary key also to the indexes. Okay. Now, when they add primary key to the index, they think I need to include primary key. But by default, any index you create, non-cluster index, will always have a underneath primary key with that. Because let's say you created index on 2 columns, but you are pulling 3 columns. So for the third column, it has to go to cluster index and get you the data. Because actual table is this the cluster index. So you have 2 columns into the index and it used for filtration. But for the third column to show you, it has to go to primary key. Okay, let me explain you with particular example. Let's say I write a query, select A comma B comma C from ABC table where D equal to 1 and B equal to 2. So what should be my index definition? Should I create index on D and B or ABC or both together? Anyone would like to answer?
So are you asking where to create the index from this query?
Yeah.
Well, so we can create one where clause D and B.
D and B. And then we can have these columns either into the index or we don't require it. So give an example. When I create a known cluster index, you will see 2 sections. Okay. One section say index key, which is let's say first name or let's say date of birth. And then the second section is included columns. Now, what do you mean by included column? What is the difference between key and included column? Anyone knows or no one has seen this before? Like most of the people who are experienced have already seen. Okay, now let's come to this query. Okay, so now this query is accessing 5 different columns, column A, B, C, D, and B. Okay, now let's say this table has column between A to Z, means it has 26 columns. Okay, now if I create an index on D and B, it will help me to filter faster. Okay, but the problem is it doesn't have ABC. Show the result, it has to go to clustered index and say, give me A, B, and C. What if I say, let me create filter on these 2 index and include A, B, C along with it. That's what the included is. Now, difference between key and included is Key will always be arranged in an order, either ascending or descending. Included are just kept as a copy of data without doing any, you can say, sorting for those. This might be a little bit different, difficult if you are not familiar with it. Is there any question here? Any question? Okay, let me take uh, silence as yes. Like no, there is no other question. So generally, when we create index, now we always need to know which columns will be part of index key, which is nothing but the where. So whatever is in the where condition, the column in where condition should always be the index keys. And whatever your extra column you are accessing, you might include them in included field or you might not, because sometimes SQL Server goes crazy. It might ask you to create include index for all the 26 columns. Let's say after two, like 24 columns, you will not create an index with 26 columns, am I right? Because it is nothing but a copy of data, so it will copy complete table. So when we create indexes, they are nothing but copy of data maintained separately by SQL Server. And the key is the where conditions. Where condition should always be index key, and additional data if you want to just show so that it don't go to cluster index to fetch the data, you can just add them as an included one. Okay. Now coming to it, this particular execution plan. Now in this execution plan, as I told you, this 1%, or you can say lazy spool, or now it's 0%, but this is the culprit. Because the moment you see a duplicate aggregation, that means the SQL Server has to recompute the same result again and again. So what SQL Server does is it goes for lazy spooling. Now spooling is nothing but it maintains a, you can say, computed copy. Let's say 1991, date of birth was 31st of December. Okay. Now for 1992, let's say the most youngest person is on 13th of December. So SQL Server knows, as you are asking again and again, instead of recomputing, let me maintain a copy. But SQL Server is very bad at doing it, because it is still a doubt, if a doubt to a SQL Server whether the expression might change during time. So what SQL Server do is it will go for spooling. It will keep a copy, but it will still keep on computing to verify whether the result it is giving back is correct or not. So when you see duplicate aggregation, you can fix it in many different ways. One is using temporary table, or one is using CT and other things. So I will show you an example of using CT. So this query takes around 13 seconds to compute, am I right? And gives me 384 records. I will show you an alternate query which do the exactly the same task. Okay. So it takes 11 seconds. And I will run another parallel query. And if I run this query, it is in less than 1 second, 384 records. So the same query, which is making my CPU server go high, the alternative query, if I keep on running this query 100 times also, this CPU will not have any impact. The moment I run that query, even a single instance, it goes crazy. Now, as I showed you, we have initially set our statistics IO and time on. So what time and IO do is it adds certain information into this messages section. So this is your result and then message. You have to copy this, go to a website called statistics parser. There's a website called statistics parser. Go to that. This is very neat tool. Just copy paste it, click on parse. It will give you a little bit more readable look. So it shows to give you the data, how many scan it has to do and how many logical read. Logical read is nothing but how much data in the from the memory it has read. When it says physical read, that means how many data it has read from the hard disk to pull that data into logical reads. Now, what is difference between logical and physical read? Let me explain you. Explain you that as well. Let's say there is a table called ABC, which no one has queried. So the data is sitting on hard disk. When you do select star from that table, first it will do a physical read and then it will move that data into logical files. Logical file is nothing but in memory, and then it will show you the output. So logical read will always be either equal to or greater than the physical read. Logical read is required because SQL Server keep the data into cache. Now, when you read data from cache is nothing but the logical read. Does that make any sense? Like, is everyone clear on this one?
Yes, yes.
Okay. So what I will do is so now I will just show you one simple example. So this is the bad query which took this much time, and this is the opposite query which is optimized one. And what I will do is I will get the statistics for the same, and we'll compare it with the original one. So if I do it, I copy this, paste it, run. So now here you see in 1200 logical reads, I'm able to do the same thing where it is taking 220 100,000 times, 1,000 plus logical reads. That means if I compress the logical reads, my query time will improve. Does it make sense? So I have to ensure my SQL Server don't do the duplicate aggregation. And now how I fix it? First I said, okay, go to the student table, get their year, maximum year, and then the maximum DOB in that particular year. So I know these are the year and this is the maximum, you can say, date of birth from the student table. Now, if I join this output with the student based on this DOB, I know in this year, any student who has born on 31st of December should come, because those students, can you close the window? So those students are the one who are the most youngest one. So if I run this query, so it is taking less than 1 second. Go to the logical read. Logical read is very less compared to this humongous logical read. So if I reduce the logical read, it will improve my performance. So let's see the execution plan for this particular query. Okay. And what I've done is I just did the aggregation before joining it with the student table. Okay. So I got the year and their maximum DOB in that particular, and then find the people based on that DOB. Now, if we see the execution plan for this particular bad query now, it doesn't give me any help where I can improve it. It gives me everything is running on parallel. So if things are running on parallel, again, SQL Server is to do one more thing. Let me show you how bad this query is. So there is something called as option, and then you can do max top one. Now this max top one is nothing but it asks your SQL Server to query this, run this query. Give me a second. So it's enforce your SQL Server to use only single processor. When I go for single processor, this will take a lot of time, and this will be the execution plan when it goes to single processor, and it says lazy spool again 1%. The statistics are almost similar. The only thing is you don't have that parallel lines going on. So let me show you back those parallel lines. So if I show you, so this is nothing but parallelism. Means SQL Server has to parallelly work to get you the output, because the data it has to read is humongous and to give you the data out of that. So what SQL Server has to do is it says so what SQL Server is doing is, okay, so it is reading a lot of data, time has increased. So what you are doing is saying, okay, what happens in maxed of one means when parallelism will not be allowed, only one processor will be working on it, then there is no suggestion. So this is the most optimized query as per SQL Server for this particular query. But when I rewrote, it start giving me one more missing index you can say suggestion. So what is missing index suggestion? It says if I create an index on DOB, because date of birth is the one where I'm filtering on, I'm not filtering based on student ID, I'm filtering based on date of birth. So if I'm creating the index on date of birth, it would further improve my query performance with 49%, means 50% less. So let me do one thing. Let me just create this index.
There is a question
Mhm.
regarding max DOP.
Mhm.
There is a server setting. Is it a good practice to use a max DOP query hint inside your query?
No. This is not during the query hint. This is when you're optimizing the query.
Okay.
So when you're optimizing the query, always refer what it will do when the only single core will be working on.
That max DOP.
Because yeah, max DOP is like you are setting number of cores or number of thread it can use to run the query.
Yep, you're basically overriding the server setting.
Yeah, and it is just for this particular query, so it is not reflecting on server setting.
So it's particular to this session only.
Not just with the session, just with this query.
That
It's not
particular.
this particular query. Yeah.
Okay.
So when you're optimizing it, you have to see what it will do when only this one core is working. Because if query run best on one core, then on parallelism it will be super fast. Anyhow, am I right?
Yeah, it would be nice if we can bring the execution plan back, the previous one, and then show them the parallelism sign as well.
Yep. Give me a second. Next up, let me just set to 0. This particular one, it will 0 means infinite. It can go for anything. Now I created the index now. Let me just drop the index.
You improved the index or the query already.
Yeah, because I created the index now, it has a different thing. Give me a second. Let me just refresh. Let me just drop this index. Now let me just show you the parallelism again. So these signs, when you see that double sign, that always means like parallelism is going on. Means your multiple core has to work. Let me just create this index back again, okay? And let's see what will be the performance of the old query, okay? So now as I created the index, though this execution plan didn't suggested me that, means when the query is bad, your suggestion, the execution plan will not have even the suggestions to do that fast. Now again, if you see this query is not improving, it's still taking a lot of time. CPU, it might not go to 100%, but it is going to 58% or 54%, but it's still high. Now, if the moment I stop the query, you will see it drop into CPU from 43% directly to 11%. And the corresponding query, which is an optimized one, where I got the suggestion to improve it further. And now if I run this query and I see that in my CPU, and I will keep on running this query 100 times. So you will never see much on the high. It's going up and down, and that's a good thing. Now, if I go to the execution plan, now it do index scan, but on the DOB index. It's not doing it on complete cluster index. Now, if I go into statistics,
Please mute yourself.
Lisa ማይክሽን ሚዩት አድርጊ።
so now if I see my statistics, okay, after creating the index, my logical read has further gone down from 1200 to 644, as I told, like 49% of the performance improvement. And as I told you, logical read or physical read are very directly proportional to the time your CPU will take. Now, one more aspect I will explain you. You will see CPU and elapsed time. Okay. Now, there is always a difference. So when you run a query, a lot of time what happens, query might run fast on CPU. Okay. And then, but it still take, let's say, 4 seconds to give you the output, because SQL Server figure it out which record to serve using the CPU, but it might take more time for you to get you the output, because network bandwidth comes and other operator things come. So to complete a query, CPU time can be bigger than the, you can say, elapsed time. Okay, I will show you practical example of this one. So here, if you see, the query returned in 11 seconds, but in CPU it says 1 minute 10 seconds. But we got the output in 11 seconds, na? Then why it is showing me 1 minute 10 seconds? Because it was running on parallel. Let's say it has used my all 8 cores to run. So all the 8 cores run for 11 seconds. So this tells me how much time CPU has to spend to give you the output, but this is the actual output. So if your query has a lot of logical read and it is taking a lot of time to process, so your CPU time will increase if it is using parallelism. So your CPU time might be greater than elapsed time sometimes, which doesn't make sense. Elapsed time is nothing but the actual time the query took you to give the output. But CPU underneath, to give you that output, how many threads were running in the parallel, that times comes as CPU time. Does it make sense?
Can you please repeat that one, please, for the CPU and for elapsed? The difference?
Okay. So we can see our query, this particular query, when I go for the execution plan. let's say this one. Let me just drop the index so that you can see what was the original plan. If I run this query, so this shows me parallelism. Means more than one core or more than one thread is running to give you the output. So when I run this query, even though this query give me output in 10, 11, 20 seconds, but in background, as multiple threads were running on, let's say one thread spent 10 seconds for filtering the data, other thread spent 1 minute to filter the data. So actual time for your CPU is more than the elapsed time. 11 second is the time when you got the output. But to give you that output, underneath how much time SQL Server has to parallelly spend on different processors to give you that data uh, to complete your query. Does it make sense? Or still there is a confusion?
Yes, yes, thank you.
Okay. So whenever you see spooling in execution plan, and that is the, you can say, lazy spool, and because of any group by into the query, that's called as duplicate aggregation. You can remove it by multiple method. One is using CT. One more thing you can do is, let me create one more copy of you can say version of the same. What I will do is I will just push the data into a temporary table, and then I will say this, and I will say drop. So if I run this query, where is the error? Oh, see, name it this auto CD. Yes, I forgot. Sorry. That if I run it, again. So now I got the same output, which is 384 records. Execution plan will be little bit different. It says, okay, if you create index on, you can say temporary table student, it will be faster, which was the original suggestion. If I create it again, it will be like 99% faster and all. But here you can do it using, first move the you can say aggregations into a temporary table, and then join with the table, because aggregation has already happened into the, you can say, the data in the temporary table will always after the aggregation. Then next time it will be faster. Does it make sense? I have written the same query in two different methods. One is with, you can say, CT. If CT you are not well versed, we will cover that into SQL developer when we'll do. But if you don't know the CT, you can still use temporary table to remove duplicate aggregation. So the moment you see lazy spool, it's a red flag, super red flag, because it's the most expensive operator. So you can just fix it by removing duplicate aggregation. Make sense? Okay.
Yes.
Let me give you one more example. So let us go back to this query again. Now see what is the execution plan. So this execution plan says 49% performance will improve if I create the index. But here when you say inner join, it says hash match. Am I right? After lazy spool, you fix the lazy spool. Now the second operator which you have to go is hash match. Now hash match tells the data from this output and this output are not in an order so that SQL Server can join. Okay, are people familiar with hash? What is hash as a genuine term? Can anyone reply? Like, do you know what is hash? Fred, can you give your inputs? Okay, let me take that question. So now let's say you are joining, say, like these are the ID. Let's say ID number 10 first, and then 2, and then 5, 4, and then you can say 1, and then say 6. So this is not in a particular order. Okay, and let's say this is called as table A, and then you are joining with table B. Now B also has data in no order. Let's say 9, 10, 1, or let's say 1. So you want to join these with this one. Now, as both of them are not in a proper order, what SQL Server does, it will generate an hash for each and every row. Now, and based on the, you can say, column you are joining. Now, what is hash? Hash is a, you can say, generally for hash, there are multiple algorithms used. so that it will generate a value from these value and then arrange them into hashing order, means like ascending or descending order, and then make a join. Because for SQL Server, it's more easier to join when the data are in order. So SQL Server try to generate hash and get the data into order first as per that hash value, and then make a join. Does it make sense?
Yes.
Okay. Now, when we see this suggestion, as a DB, you might not be getting into each and every query a lot of time. Now, now this comes our DBA part. When I see any, you can say SQL Server or something, what I first look into, I don't go into the query first. I go into the missing index first. So if I go in this query, this is nothing but a missing index query. I will share it with you with post session. So if I run this my query few more times, what you will see is the output of this query will change, because user seeks is 6. It says 6 times this query has been called, and if you create the index, it will improve the performance for every user by 53%. Let me run this same query multiple times. Kindly ignore, sorry, background noise. There is a construction work going on near my house. If you are able to hear it, sorry for that. So here you see a number of time I'm executing, I am always getting this user seek increased. So now, when how as a DBA, when someone says suggest me something to fix my server, I never go for each and every query. First, I go for missing index, which tells me which are the indexes which are required to improve the performance. So for now, let's just create this index. Okay. Now, right now, if you see execution plan has hash match, because when I'm saying take the year and date of birth into a temporary table, let's say into the temporary table, and then join with the student. Now, neither student has date of birth, as in you can say their primary key. You can say a sorted index, because date of birth is not a, you can say not having an index. So if you create an index, that means data will automatically be in an order. So if this is a date of birth, then it will start from 1, 2, 4, 5, 6, and 10. So it will arrange the order. So if I create the index, what it will do is it will create an order onto a data, and when you join that particular thing with this particular query, you will see the hash match has gone. It has converted into nested loop. Now hash still has to you can say aggregate somehow, because if you see we are joining based on student date of birth, and this is also coming from this table date of birth. So this table is not a proper table, so it is not suggesting any index on it, because it's just a query. So anyhow, this is date of birth in student is sorted, but this is not sorted into this particular thing. So if I go into this second version of my query, what I will do is I will create a temporary table, and I will say create index idx and temp on hash temp, and let's say dob. I will say create an index also. Now if I run this particular query, I will see there is no table scan is coming, because there is no primary key to the index. You can say to the temporary table, we don't have any primary key, so index can. But if you see now in the last, when you are joining the computed data with the actual you can say index is going for seek, this is going for scan, but the column is not having any hash. That means it doesn't require an hash to order the data, it already have an index, so it can improve. uh, is so far I am clear? Like, is there any doubt? Okay, so now let's come back to the PPT. So first thing what you have to do is you have to always check hash match. Spooling, first is lazy spool. If it's there, big red flag, fix it. Your server will have a performance improve boost. And the moment once you have done spooling check, then you have to go for hash match. Hash match always tell the data you are joining are not in a proper order, so you might need to add index to do it. Now let's come to the third one, which is key lookup. So far, any question on hash match and spooling, because we won't be repeating the execution plan again. From the next session, we will be going further on. So far, any question? Okay. Let's go to key lookup. Now, what I will do is I will create this index. Okay. Let me
I'm
drop
sorry,
the
I have
index.
a question.
Yeah, please.
So can you explain to me like how will improve, like by creating a timetable, how improve it the performance? I mean, it's still the script is looks good to have a good index, and then everything looks good, but when you run it, still it takes time. So at that point, like when you create a timetable, it will improve it, but I don't understand what the logic is.
So temporary table I'm just creating so that I don't have to compute the maximum date of birth for that year. I will have to temporarily store it in some place so that I can join further. Am I right? So because I need to fetch the most youngest student from every year. So first I need to fetch the year and what is the maximum DOB. Give me a
Okay.
second, please. Put there my icons. Okay. So I need to store this computed aggregation somewhere and then we'll join. So that's why I have to use temporary table. It might see the thing is there are multiple ways. As I told you, with CT you can do or with temporary table you can do. The whole concept is it totally depends upon you which approach you take. And sometimes CT becomes very easier and sometimes CT become very difficult when the queries are sub queries are too big. So it's always good to be, you can say, flexible enough to just try different options which works best for you. Okay. Any more question? Kindly feel free to ask. Even give the feedback if you are not understanding at all. We can figure it out that as well to help you out with that. Okay. Now what I've done is I dropped this index, and what I will do is I will say create an index on date of birth and first name, not the last name. Okay. Let me just remove this bracket. Let me just create this index. Now, if I run my query, let's go to the execution plan again. You will see a key lookup happening into this execution plan. Am I right? And why that's so? Because it is now going for index seek because of this index, because it has date of birth and we are joining based on date of birth. But the second thing comes is first name. But output contains first name and last name both. Index doesn't have the last name. So what it has to do is it has to go to the cluster index to fetch the last name. So I cannot move mouse on this particular side window which is opening. But here you see output list into this in the bottom. Is everyone able to see this pop-up window which came? You look up at the bottom. You see the output list. It only went for last name to the table cluster index to fetch that last name value because your query output contains the last name, but you can say the index doesn't contain, so it doesn't have that data. It has to go to cluster index to fetch the additional information. Any question? Fred, are you there? Hello.
Yes, Yogesh.
Okay. So tell me one thing. So far, is everyone able to get together? Because if you want me to stop here and you want to go through the scripts by yourself, we can go and you can say continue from here tomorrow, or you want to go further because it will go more, you can say, complicated further. If that
Yeah,
works out.
yeah, the floor is open. So if somebody has a question, he can or she can ask. Otherwise, let's continue until what?
Yeah. Also, like if like anyone feels like this is too much for one day information and you want to try it by yourself, I can share the script. That also we can do instead of like just adding more information on top of it. So be open because I know performance tuning, if you haven't done it, becomes overwhelming sometimes.
I know, guys. Let's participate.
We're good. We're still following. Go like if we are quiet, that means we don't have questions. So please continue your session.
Yep. Otherwise, if things are not clear, he can revise what he discussed up until now.
I think it is also great if you can share us the scripts or
Yeah,
Yeah, I will be sharing the scripts with after the session. That should not be an issue. But my question is, till this point, if everything is clear, and you want to first try the script first, or you want to continue from now, like now itself,
I
because
would
it's
suggest to continue.
okay.
I think the session has been recorded, so if anybody has a problem, they can
Okay.
rewatch the recording, see what they can do from there.
yep. So you can proceed.
Okay. So far, what we have seen into, you can say, our execution plan is like spooling, hash match, and key lookup. So these are the three operator in the same order. First thing you have to address is the lazy spool. Second thing you have to address is hash match. Third thing you have to address is key lookup. Now, sometimes key lookup becomes challenging to address because you cannot have all the columns into the index. So this was a small example. We have a small table, we can do that. But when the table has 100 columns, sometimes it might use index to filter out 100 records, but to fetch other 100 columns, it need to do a key lookup. So to fix it, one is ways like you add the fields into included. But the second thing is, if it is too big to have like so many fields, so it's always good, okay, let's let it do a key lookup, but ensure our index seek runs far better. Okay, now coming to it, the next part. Now so far what I've explained to you is from execution plan perspective. Okay, now I will explain you from the developer perspective, what are the mistakes they generally do which cause these kind of trouble. Okay, one of the thing is called as bad views. Now, what is bad view? Everyone knows what is views, am I right? It's nothing but a stored query. Okay, just show you one more example. I think these are different plan. Yep. For example, okay, so here what I have done is, so there is a table called customer and order tables. What I'm doing is I am saying get me all the, you can say, sum of fright, means like sum of all the total amount of orders for that particular customer. So if I run this query, so this is a different table. So if I run this query, it says that this customer has done that much shopping and other things. Let's go for execution plan. So it contains lazy spool. Okay, okay, now I will show you one more version of the query. It's exactly the same thing. The only thing changes upper. Okay, if I run this, the second query, and go for execution plan, then there is no lazy spool. Exactly the same query. The only difference is I have used a function while making a join. Okay, now this is also a correlated subquery, but SQL Server is intelligent enough to know, okay, this is a duplicate aggregation, so let me not use lazy spool, because it is able to detect in above the top case. It was unable to detect because we were grouping by an expression which is nothing but year, and then we are putting a bare condition based on an expression. So now in these two queries, the only difference is this upper function. Now in this particular case, so here you see the performance of the same query is 82%. Like so here you see the cost. Now this is nothing but a collectively cost for both the queries when I ran. So the second query where there is no upper function, it is working for 8, like it is only taking 18%. For the above query, it is taking 82% because it has lazy spool into it. So sometimes your SQL, so here it feel like it's a duplicate aggregation, but SQL Server is able to identify. But the moment you used function or expression or any other thing onto your, you can say, your where conditions where you are joining the subquery, it will always force you to go for, you can say, a lazy spool. Any question here? I will show you a few more things. So spool, there are other type of spooling as well. I think it won't reproduce because today it was not producing. Sometimes execution plan changing based on a system setting, so I can ignore this particular thing. Now coming toward sorry, bad views I wanted to show now. Give me an example of it. Okay, so I think this view is already there, so we can ignore Okay, it created the view. Okay, so I have created a view called as orders, joining with order detail and product. I'm fetching order, product ID, order date, customer ID, discount, and product name. So I just want to get what are the product been ordered. Now, if I do this query and I go for execution plan, it is you can hash find another thing. So here, just ignore the previous one. What I'm just about to show you is how just a bad view can cause a trouble. Okay, so and these are the mistakes which developer do generally. So okay, so this is a query which is what I'm doing is I'm joining order with order detail and product, and when I do select star from this view, it is running the same query. So execution plan for this view and this query is exactly the same, because these both queries are exactly the same. View is nothing but a stored query. Now let's say there is a problem. Someone want to fetch a quantity as well along with the product name. That in that you can say order how many of product quantity was been booked. Okay. Now when I have to do this, it's I for this particular query I just need to add an extra column there, which is nothing but the quantity, and the data remains as it is. But as this view was there, what developer will do is they will join this view again back to order detail just to fetch one extra column, one or two extra column. Okay. Now, if I compare now these two queries, where one place I have used view to get just few additional column by joining it the same table, and in the other one where the table were already joined, I just added extra columns. So if I run it, your execution plan for query changed. So what person has done is he has just added an extra column which was not present in the view. Instead, he should have gone to the view and alter those two columns. No? But what developer will do is they will rejoin the view to the same table again and to get the data. But underneath, it doesn't know how much performance impact it has. So this one is taking 65% of this batch, and this one is taking 35%. More you can say columns and more tables you add, it will becomes more complicated. So it's always good for you to suggest the developer if you require certain extra column in the from the view, add into the view instead of you can say uh, rejoining the view to get those additional columns. Make sense?
Yes.
Okay, and this is recursive CT. Okay, yeah. Now, as I told you, lazy spool might happen in recursive CT as well. So here you will see lazy spool, because the recursive CT by default SQL Server no, it has to perform duplicate operation again and again to get few data because it's a recursive thing. So you will see an lazy spool here, but you cannot do anything about it. So this lazy spool is acceptable because if you see there is no group by and other thing are happening, no aggregation happening in that sense. In that sense. Okay. This is case like where lazy spool appear, but it's not a red flag if it's a recursive CT. When it is happening because of a group by and other you can say operators, then definitely it's duplicate aggregation and we need to fix it. Okay, I have one question. So and it's a you can say small you can say test kind of a thing. So let's say we have customer table. I want to fetch his most recent order, its fried and its ship and order date and ship country. So this is my output. Tell me what are the alternative approach to get the same data.
Is it from one table?
Yep. So what I'm trying to fetch is I'm trying to fetch the most recent order ID of the customer, total amount, what is the ship name, order date, and ship country. Most recent order. I'm not selecting all orders. For that customer, I'm selecting only the most recent order. So let's say you get this query. Even if you see the execution plan, it's not that complicated. It's simple only. How you will rewrite this query?
Can we see the query so that we can think? Thank
Sorry?
you. Yeah, can we see your screen so we can think? Okay.
Yeah, sorry, I was talking to my friend, so I have to mute for a second. Yeah.
So you have 5 different select segments.
Yep. See, the
What?
main task is you have to get the most recent record of the order, like most recent order of the company or a customer,
So we
and
have to.
different information.
So
What are the
we,
different ways you can rewrite it?
I think we have to filter it based on order date, right?
Filter is correct. So see, what I'm doing is I'm writing a subquery. I'm saying, okay, send me the top order ID of the customer, order by order ID descending. So I will get the most recent order. And then I'm running the same query and asking to get me the freight. And same query I'm running, just getting the ship. So it's a repeated query, but the column is different every time. Am I right?
Yeah. So you just need to write one query, including those columns, and filtering out by the order date.
Now I want someone to write a query to give a try. How you will do that? This is one of the most common thing in the dashboards, where you want to see most recent query whenever there is an insurance company and other thing, yeah? And
So
you will have this stuff.
I would write a query, select order ID, freight, ship name, order date,
Mhm.
and or I mean order by the order date.
But you will get all the orders of the customer. I'm getting only one. How you will do that in one query?
What do you? So you wanna see the order date, the recent order date, right?
Yes, I want to get the recent order information and the customer name.
Let me see. Okay, ship name, order date, country.
Most of the dashboards, whenever there is an application, you will find these queries coming up, where you need to educate developer not to write these kind of queries.
Maybe
Nothing
using
wrong.
maybe using inner join
No.
or
So
this.
so if you join order table with customer tables, you will get all the orders. Am I right?
Yeah.
I want only one. And you cannot use max, because the problem with max is, if you want to get max of freight, so his older order might have the maximum freight. So max doesn't give me the recent one, it gives the maximum one.
Mm.
What about the subquery?
It's already a subquery, no?
No, I mean the sub. This is like, is it two subquery here, or
This is subquery only, no, to get the data.
so can we minimize those select statements like that? Those 4, I guess. The select top. Can we minimize that to?
Can you add that into chat so that we can read?
Okay.
And it's open for everyone. Kindly take an attempt how you will rewrite this query. By end of this whole performance sessions, na, I will ensure like at least you will be able to find out what is the problem the moment you see it. How to fix it? It sometimes it goes on experience to experience. Like my experience is more, so it takes less time for me to find out how to fix it. It might take some time to you, but after all this performance session, you will be able to accurately find out what is the issue, when it's a deadlock, why it is happening, what is the reason. Because a lot of time now, when deadlock happens, people restart the server or they kill the process, and after 1 month or 1 week, again the same thing comes up. So you need to find the root cause of the deadlock, how you figure it out, how do you fix particular, this is a problem, how you figure it out that. So we'll cover up all those things into upcoming sessions. And just to tell you, like a lot of time, DBA doesn't learn SQL query writing. Believe it or not, it's the most important skill, because a lot of time your developers are not equipped with rewriting the query. So you need to give suggestions to them. Anyone? Is anyone even attempting it? Sorry, so I can read it. Row number partition by. You can. I want complete query here actually. Partition by. Can you please the complete query, whatever you're typing?
I'm sorry, I'm still typing. When I enter to make a shift, I did not click the shift, so it goes without finishing my query. I'm trying.
Okay.
So what if we use join and put like on the where condition the order ID and like the customer.
There is no order ID.
ID.
There is no order ID. You have to find the most recent order ID. So there is no where condition in terms of order ID. Give a try. Write the query and post it into the group. We'll go through one by one into each one of the query.
Okay.
Just a question: has anyone explored graph tables in SQL?
Okay, never mind. I'm lost. Don't. Are you still waiting my query?
Okay, no problem. My question was: has anyone used graph table into SQL Server? We have graph tables. There is a type of table called graph table, which was introduced in SQL Server 2017. So there will be one session where I will explain you how we remodel the database depending upon the project requirement, like this table structure suits. Right? We need to get more people to get engaged. Not all people are engaging into the session.
So we're filtering it by the shipping day, right?
Yep. Give a try. Let me just post the columns into the chat so that you can try. So table name is customer. and orders, and column name is company name. Order ID I have to fetch. Order amount, let's say amount, better easy term to say. Order ship name. And why I'm asking everyone to attempt it is because once you attempt multiple times and then you know this is the right solution, you will remember it. If I just show you the solution, you will forget it the next session itself. So give a try. No, top will not work, Sophia. Just top will not work because when you do top, then you will get as an output all the, like, let's say 100 rows are there, it will just show you one row. I want to get all the customers. One is limit is not SQL Server syntax, but limit will only give you one record. I want all the customers. Direct join will not work.
Oh, you said direct join will not work
No, it won't work
if we
because
put
direct join will produce all the combination, and then you are saying top one or limit one, then you are just getting one record out of it.
so selecting the company name, order ID, order amount, and order shipping address, and then joining with on customer ID, order by order ID is that.
So when you join customer with orders, you will get all the orders of that customer. You are not anywhere specifying. When you say order by
So
order ID
so
descending,
so okay, we need to add a where statement here.
figure it
Oh.
out. Let me show you the output of the query which you I think test it. I might be spelling it wrong, so kindly correct me. Test it has written a query. Let me just show output of that. So what I do is select, let's say, from customers, see inner join orders, go on o dot customer ID equal to c dot customer ID, and I say c dot company name, comma, or dot, or let's make it all the things from order. And if I say top one or limit one, which you says, it will give me just one record out, which is incorrect. I want all the customers. So inner join will not work. Where condition you cannot put because there is no where condition. I want to get all the customers. So the whole concept is either it will be a correlated subquery with a join, and which will be a complex join, or there might be other approaches to do the same. This is the one of the most common thing, I have to fix for most of the companies whenever I see their data, because the programmers are writing this particular syntax of getting the data, and we can do a better way. So yeah, give a try again.
Maybe we can write kind of procedure to pull the recent date, the recent order.
Why I have to write a procedure? It's a query. Okay, let me give you a hint. Has anyone used cross apply before or outer apply? Okay, so the hint is you can do with cross. There is a complex correlated subquery join which you can do. I'm pretty sure most of the people will not go close to that because it's kind of a require a very good SQL skill to do that. But the second easiest way is cross apply. Okay, let me show you my screen. Okay, now let me give you an answer. I'm happy to see people are applying, trying different things. So it's good to see. Now coming to it, this particular thing. Okay, now there is something called as cross apply in SQL Server. So what I can do is what cross apply do. It first compute this query, this particular table, and for every record from this table, it will run the subquery. In this one particular subquery, I can say, get me all the data from orders where the customer ID is matching from the outer customer ID. So this is correlated subquery with a cross apply, and I can get the data, same data. Now, let me compare the execution plan of this one and this one. The execution plan. The above query which developer wrote, it's kind of funny looking execution plan, not a simple one. And this is 81%, this is 19%. Now let's go to the results. So this has around 91 records, but this has 89 records. It is missing two people because the two people are the one who never placed an order. So to fix that, there is something called outer apply. It's like an outer join kind of version. Now if I run both the queries, now my result set will match, and the performance of my query is far better compared to the what a developer wrote a query. So when you want to get same column, different column with the same subquery, you can use cross apply or outer apply to compute it once, get all the data, and use it. Or as I told you, it will be funny looking complex join. This is the complex join. I'm pretty sure not everyone will be able to write this query. As it, it will produce the same output, but it is far more complex in terms of how you get it. Writing this query, but cross apply seems very simple syntax. A very simple looking execution plan. Was anyone near close to either this query? I'm pretty sure this is the most common thing which people like. It comes into the mind. Second, there should be a way I can hide my own screen.
I have a question.
Yeah, please.
Okay, we could have also used row number over
Partition by.
partition by, right?
But that is also correlated subquery, am I right?
Yes.
Yeah. So either you write a correlated subquery, one way of doing that. Partition by, yes, we can use row number and other thing. But yes, but it will not be like direct inner join. Direct inner join will not work. You have to use a correlated subquery and do it. And partition by will do the similar kind of a thing because you have to partition it by customer ID and get that. So mostly partition by one, inner join, and this one will have the similar performance because both of them has to trigger it. But the problem with outer apply and cross apply is for every record, it triggers this subquery. Okay. With the partition by, you might, so the row number thing, you might have a better execution plan when the data is too big. Because in that, it will become a part of the same execution plan. It will not trigger the subquery again and again. But cross apply sometimes come handy. Let me just show you one more use of cross apply. Sometimes it is used in data transformation as well. So I know this might not be your profile, but it will give you more knowledge on cross apply. Just give me a second. Getting one call. Okay. So let's say this is my customer table. If someone asks you to create a duplicate of every row, how you will be able to do that? Means I want this row to repeat 2 times or 3 times or 4 times. One way is union, am I right? Like union 4 times, 5 times, 6 times. The second way is I can just say cross apply, and I will say select 1 as number, union select 2 as number, and if I do it, everything will multiply 2 times, like order by let's say customer ID. Simple hack. Every recopy comes 2 times. You want to make it 3 times? Make it one more union. Cross apply sometimes come handy when it comes to, like, you can say, manipulate data in different manners. But cross apply resolve your this particular trouble where the people has written so many expressions. Just the only thing changing is the column name and the same subquery run. So you can run it once and use it with every, you can say, every recorded. So this is one place where developer goes crazy. Bad views I have explained you. So let's come back to the slide again.
I have a question on views.
Mm-hmm.
So
Yes, please.
when we use views in queries, for example, like joining or inner joining or whatever.
Mm-hmm.
So the values or the data retrieved by the view is created on the fly.
Yeah, it's view is nothing but the stored query. So whatever the view definition, it runs the same query in the backend. There is no data cached for view, so it's exactly the same query. So if you are running the same query along with the view having the same query, they are exactly the same. There is no change in terms of, you can say, output. The bad views is nothing but like where developer is just not altering the view and adding few columns, but instead of that joining the same view with the same table just to get additional columns. And this is one of the most common thing I've seen in development. Like, see, generally thumb rule of development is like, if something works, don't change it. Am I right? That's how the developer mindset works. But as a DBA, when I see the queries which I need to optimize, my whole brain goes haywire when I see, okay, you are just not adding an extra column to the view. Instead, you are joining the same table again and again and again. Output wise, it looks exactly the same, but internally it joins that table back to the same. So it becomes kind of self-join kind of a thing, and then start giving you the output. And that in the execution plan, so it will just increase your logical reads the moment you do it, logical and physical reads. So it's better just add an extra column to the view, alter the view definition. This mindset of like, don't change something if it works, sometimes backfires, especially when it comes to databases. Okay, does that answer your question?
Yes, it does. Thank you.
Okay, after the bad views, we have seen subquery.
I have a question. Can you please show us how the outer apply works on the result?
Yes, please. In terms of execution plan, or
Yeah. No, just the result. So when you run that query, what result did you get? Like, can we see us?
let me run both the queries so that you can see the result set. It has one column extra. Let me add that as well. So it should not be an issue. Now, what was this ship name? Let's add that as well, so that you can see both of them have exactly the same output.
Okay, so which query did you run? Did you run like 2 different queries for this one? I thought
so
the question is,
first one is the query which is the original query, and the second output is the outer apply one.
no, can you please run just only with the outer apply? So I
Sure.
will. Thank you. So what I don't understand here is how the SQL Server gives a priority, since we have, for example, I see that like null values. That means I think
null value here means the customer has never placed an order. That's all. This customer never placed any order, so that's why there is no data for this. So null value is related to that.
So how is it going to be effective? Like, we're using the order by because we want to sort out, and then if the
let's look into this query. What this query do? Can you spell it and explain me?
Order by. So okay, this one, it gives us the top order date and it sort out with descending order.
By
And
order ID.
with
Means
the
the
order
most
ID. Yes.
most recent order date it gets me.
Yeah,
Right?
but my question is, what if they have, okay, since it's on the same table, right?
Mhm. And if you can you read this particular query, just forget the column names. Just see this query is exactly the same.
I mean, I thought like the order by it's a different, like you're using different column, but what I see is it's all are sorted by order ID, right?
Yeah. Here also everything is sorted by order ID. This query has the same bottom half.
Okay.
This is exactly the same. The only thing I've done is added few more columns.
Okay, I thought it has difference with after you write the order by, you put like different 4 columns. That's why I get confused.
No.
Okay.
So the whole concept is instead of running 5 different subqueries, I can get 5 columns at a time or in the same time.
Okay, but
When
if we differentiate our column when we sort it out with order by, if we differentiate our column, it doesn't work with outer apply, right?
No, so that's the problem statement change. Na? When you say you want to order it by something, then the query becomes different. So the whole concept was to get the most recent order ID that can only happen with the order ID descending.
Yeah.
And I don't want to go for dates as well. Sometimes some places they won't use time, and you might like they might have separate column for time and other instead of you can say order date. So order date is separate and time is separate, and order date if you do, you might get some other result. So order ID is always incremental. It's an identity field. So the most recent order ID will always be the most recent you can say record of the customer.
Okay, thank you.
Okay. Anyone has any question, please? So what we have covered is one is bad views when the person just add an additional column just to join to get from the table with the view instead of altering the view. And the second is subquery minimization. Subquery minimization, I have showed like 5 subqueries we can minimize to 1 subquery, and this query will perform more bad if we have more columns to add. But this query will perform better because we can add the more columns into this. You can say as an output because it's only touching the last record of that particular customer. So subquery minimization comes up, and the reason for both of these issues is the lazy developers. So we need to always see like whether they have just done the thing because they found it easy or different thing. Okay, so let me just tell you like what will be the next session thing. There is something called a partitioning in SQL Server. Everyone might be aware of it, but partition in executional plan, when how we look into executional plan to see whether the partition elimination is happening. What is partition elimination? Let's say your partition has million of rows. Let's say this partition has data before 2003, from 2003 to 2004, 2004 to 2005. But when you write a query, how from execution plan you know the partitions are getting used properly. So this we will cover you can say tomorrow in the next session, because it will be kind of a little bit different from what we have done. But so far what we have seen so far, has anyone has any questions related to it, please? What I will do is I will share you this PPT and the script along with the database backup, so that I want everyone just to run, see execution plan, how it works, so that everyone can get familiar with it. So let me just rewind it. So first is just time is not a parameter of a bad query. It's always logical and physical read, because time is always related to that. More data you read, slower the data you will get, or more data to process, slower the data you will get. And then checking in terms of performance, you can say operator business, execution plan has a lazy spool and a group by, it's a red flag. You fix it, you will become a superhero for that particular query because you will save it. How you do it? Using CT or by using temporary tables, you can do that. Then coming to the hash match always tells, that means when you are joining between two tables, the columns of both the tables on which the join is happening, they are not having proper indexes. So if they have proper index, means they will be in ascending or descending order. and the join will work a little bit faster. Well, not little bit, very faster sometimes when the data size is bigger. Then comes to key lookup. Key lookup is nothing but your index is missing some data, so we can add that as an include column to it, so that you don't have to go to cluster index to fetch the data. But the problem is not all the columns which are required in select statement we can add to include, because let's say some columns are varchar max, we cannot have that into our index. So the key lookup has limitation. It's always courtesy of DBA or the developer which columns to be added to the index. So it totally depends upon you and the way you are looking at the problem. And then it comes to bad view and subquery minimization. Subquery minimization, you do. So a lot of times SQL Server, now what people do is they will say, okay, this query is causing my server problem. No. Sometimes you will have 100 queries which are accumulating CPU, you can say memory pressure and other thing. And then the last query comes, which is most heaviest one, and cause the problem. So for us, the most heaviest become the problem. But as a DBA, when you look at it, you have to look at all the queries which is running. So in next session, we'll go for partition elimination and all. And Sajid will go, which will be like a little bit simpler one. And after that, I will show you how you capture the, you can say bad queries, how you analyze that. I know like a lot of you people are using either the tool or you are using query store. I am very, you can say raw. I generally use the query written by myself to find out that. So I will share those queries as well. Any questions so far? I think we can conclude today's session then. Please feel free to ask the question. Believe it or not, performance, you will find rarely a lot of people like doesn't teach performance. So whatever you are learning in this session will be kind of unique. Let's say you are going for an interview and you are telling like you do performance optimization, it definitely attracts, because all companies are struggling with performance problem one way or the other way. Okay. So ensure if you have any question, feel free to ask me. Fred, are you there? All right, Fred has left the call. Yes, you.
Thank you. I don't have any question, but thank you for the enlightening session.
You're welcome. Thank you. Fred, are you there on the call? I think he has dropped off. I don't know. Okay, I think we can conclude. We'll connect tomorrow again at the same time, and we'll go through the further more things to the performance. Thank you, everyone. Take care.
Thank you.
Thank you.
Thank you so much.
Thank you.